this video, I am going to explain you about the platelets. Competency for the today's class. Describe the morphology of the platelets and normal count and its variations. Morphology. These are small and anucleate cell fragments. As we know, these are smallest of whole blood cells. Okay. There is exterior coat here and these are granules. Here is open canalicular system, deep tubular system, dense bodies and glycogen molecules, trilaminar cell membrane, and here you can see submembrane area. Okay, this is about the structure of the cell. Now dimensions. It has 1.5 to 3 micrometer of diameter. Cell membrane is trilaminar unit. You seen from here, it is trilaminar unit. You can see there are three colors. Okay, it has negative charge on its surface. So once if it has negative charge on its surface, it prevents resting platelets to attach each other. So simply it prevents aggregation, so it prevents clotting in normal flow of the blood. And it have receptors for collagen, ADP, von Willebrand factor and the fibrinogen. Cytoskeletal system. Two cytoskeletal systems, membrane cytoskeleton and the cytoplasmic cytoskeleton. Membrane cytoskeleton provides stability to the membrane and it plays important role in platelet spreading following their adhesion to the vascular endothelium. So once they get attached to the vascular endothelium, it helps in spreading. Okay, and we have cytoplasmic cytoskeleton which has extensive microtubules and the filaments. These helps in contractile system. Here you can see I written well developed contractile system. So these cytoplasmic cytoskeletal system is present within the cell. So it helps in contracting, which expels the granules outside and also granular contents outside. Now we will discuss the cellular system. Okay, the open canalicular system and the dense tubular system. Here you can see I have marked some of those which are open outside. Means I will read here. It eliminates the dependence on migration of the granules to the periphery for exocytosis, which means here there are granules. To travel to the outer membrane, it requires time. So if you have open canalicular system, these are open outside already. So once if they fuse with this, the contents get easily released outside. So it enhances the degree and rate of platelet release. This dense tubular system is formed by residual endoplasmic reticulum. System is found in close to the open canalicular system. They sequester the ionized calcium. So release of calcium from the dense tubular system facilitates the platelet release. As we know, this calcium always helps the exocytosis, the process of exocytosis. So this dense tubular system has calcium. Release of calcium releases the granular content, which means helps in the exocytosis of the vesicular contents. Okay, you can see the same phenomenon happening at the end of the neuron. Here I am going to mention about the platelet granules. There are alpha granules and there are dense bodies. Okay, alpha granules contain adhesive proteins, growth factors and the coagulation factors. In adhesive proteins, it has fibrinogen, von Willebrand factor, fibronectin, thrombospondin. Growth factors, platelet derived growth factor, transforming growth factor beta, fibronectin, platelet factor 4 and the thrombospondin. Coagulation factors, fibrinogen, factor 5 and 9. Here dense bodies has ADP, ATP, serotonin and the calcium. These are the receptors for von Willebrand factors and some other factors. Okay, looking at the normal counts, Normal count of platelet in blood is 1.5 to 4 lakhs per millimeter cube of blood. There are obviously two conditions. One is decrease and in another one is increased platelet counts. In decreased platelet counts, we call it as thrombocytopenia. There are reduced cells, which means less than 1.5 lakhs per millimeter cube, the lower limit, less than the lower limit. And we have condition called critical count. When there is reduced count less than 50,000 per millimeter cube of blood, it occurs in significant bleeding, or else it causes significant bleeding. And thrombocytopenia occurs in idiopathic thrombocytopenic purpura (ITP), aplastic anemia, hypersplenism, acute leukemia, and cytotoxic chemotherapy and radiation, where they suppress the bone marrow. Thrombocytosis, when there is increased count more than 4 lakhs per millimeter cube, occurs in polycythemia vera, chronic myeloid leukemia, iron deficiency anemia, splenectomy, chronic infection, surgery, and acute hemorrhage. This is the end of the session. If you have any doubt, please drop down them in the comment box. Thanks for watching video completely. Stay safe, study safe. Thank you.